Hello once again, my fellow learners. We are now here in the quarter 1, module 4 of grade 9 mathematics, and that is the activity 2 that can be found in your module. That is Find Me. Hope you enjoy this. Okay, in the activity 2 that we have here a certain instruction that we have to do, and that is solve each quadratic inequality and choose the answer from the box below and write the correct answer in the space provided before each item. So we have that one. So here it goes, the process. We have here a given problem for number 1, and that is x squared plus 8x plus 7 is greater than 0. So to solve this we are going to factor this one first if this one will be factorable. Since this one is factorable by means of since the quadratic term, its numerical is 1, so all we have to do is to look first is to focus ourselves from the given constant term, and that is 7. We're going to look for the factors of 7, and that is 7 and 1, and its sum of those factors that we have is 8. So 7 times 1 is 7, that's correct. Then 7 plus 1 is 8, and that one then. So the sum should be the same with the numerical coefficient of the linear term, which is this one here. So if that would be the case, the factor now of this inequality is x plus 7 times x plus 1, which is greater than 0. So every factors will be equated to 0. So we now have here x plus 7 is equal to 0, and the other one is x plus 1 is equal to 0. So then again is this one now is x now is equal to negative 7, and the other one is x is equal to negative 1. If the given equality is greater than, so we have here a certain thing that we're going to consider, and so this is now the pattern that we're going to follow. If the quadratic term or expression, which is a is represented by ax squared plus bx plus c is greater than 0, or just we say ax squared plus bx plus c is greater than or equal to 0, then we could now say r and s are the roots of the certain quadratic equation ax squared plus bx plus c which is equal to 0. Then since it is now greater than, so the things that we're going to get the solution set of this is x is less than r, or x is greater than or equal to is greater than s rather, where r is less than s. So in other words, the value of our r is lesser than the value of the s, or and the other way around, if this would be greater than, we now have here x is less than or equal to r, which is the lower value of the root, or x is greater than or equal to s, which is the higher value of the roots. So in this case, going back to the given roots that we have here negative 7 and negative 1. Since negative 7 is lesser than value of the negative 1, so we could say that further that the value of our x to get the solution set is x is less than negative 7, or x is greater than negative 1. So we could say further that this one here, the set of all x such that x is less than negative 7, or x is greater than negative 1. So we have that. So looking back to the given problem that we have, so accordingly, this is now what we asked for and this given, so we are going to write that one there. The set of all x such that x is greater than the set of all x such that x is less than -7 but less than, or x is less than -1. So we have that one. So I would have to write that one there. We have that as the value. Okay, so I will be able to fit it in. So we have that. Okay, let's proceed to problem number 2 that we have. And so x is x squared minus 7x plus 12 is less than 0. So for us to be able to have this, since the we are going to check this one first, if the quadratic inequality is factorable the left hand side of it. So therefore, since the so we are going to check now. Since the numerical here is 1, so therefore we're looking for the factors of 12. And since that the middle term is negative, so we could choose the factor now to be -4, -3, -6, -2. Another one is -1, -12. So among this, -7, the sum of this 2 is -7. The sum of this 2 is -8. The sum of this 2 is -13. And so if this would be the case, the only factors that we have of 12 which is the same with the -7 as their sum if we're going to add it. So this one. So therefore, from the inequality that we have there, x squared minus 7x plus 12 is less than 0. Then the factors now is x minus 4, x minus 3, which is less than 0. So okay, that would be how to deal with our given. And so to go further of this, and it seems that we could now give the two a factor. So we could now have set every factors to be 0. X minus 4 equals 0, and the other one is x minus 3 equals 0. So therefore x now is equal to 4 and x now is equal to 3. So with that we have that one. Now since the given inequality that we have is less than symbol, so there is a pattern that we're going to consider for us to be able to collect or to give our solution set of the given. So if the quadratic inequality represented by ax squared plus bx plus c is less than 0, or other way around, ax squared plus bx plus c is less than or equal to 0, then we have here two roots r and s represented by the quadratic equation given. Now then again, the r value is lesser value than the s, so we can say further that x is greater than r but less than s, or for the first. And for the second, x is greater than or equal to r but less than or equal to s. You have that. So in this given problem that we have, since 3 is lesser value than 4, so we now have here arrange. We are going to arrange further. So we now have here 3, then 4. So to get that one, then so x is greater than 3 but less than 4. So we could say now that the solution set is x is the set of all x such that x is greater than 3 but less than 4. That is how we cater with the answer that we have in the given problem in number 2. So going back to the given, so we now have here the answer should be this one. Okay. So we now have here that one there as the value. Okay. So let's proceed to problem number 3. The problem number 3 is x squared minus 3x minus 4 is greater than 0. The first thing that we should do is try to check first if it is factorable. Since again the given now is of the quadratic term is 1, it's numerical, so we're looking for the value of the constant term, which is negative 4. Negative, so therefore, there's no other thing that we could find in the middle term that we have, since the given now of the constant term is negative 4. So we could see further that the given that we have is, so we're now able to consider now that the solution of this is we are looking for the factors of negative 4. So we could see we could either 2 negative 4 then 1, or 1 negative negative 4 negative 1 then 4, because the product is still negative 4, right? So its sum now is negative 3. The sum of negative 4 and 1 is negative 3, while the sum of negative 1 and 4 is 3. So we could not give the factor, since it is now a factor of negative 2 and 4, because its sum is 0 automatically. We can now use this one as the difference, the sum, a difference of 2 squares. So then again, so this is now what we select among the 3 choices that we have. So we could say further that x squared minus 3x minus 4 is greater than 0. So the factor now is x minus 4, then x plus 1 is greater than 0. So equate both factors to be 0. So the first one is x is equal to 4, then the other one x plus 1. So x plus 1 is equal to 0, then x is negative 1. We could now get that one then. And so, looking back for the things that the pattern taking place for the greater than or equal to symbol. So we could say now that our answer should be either way that we have. So negative 1 is less, negative 1 has a lesser value than 4. So we could say now x is less than negative 1 than the other one, since x is also equal to 4, so x is greater than 4. So r is less than x, meaning to say that the rules that we have are both, we could now say that one then, how to locate the certain inequality symbol that we have. And so we could say further that the set of all x such that x is less than negative 1 or x is greater than 4. That would be now the answer in dealing with this kind of problem number 3. So in dealing with such problem, so we could say now that the answer that we have is this. Okay? So we have that, okay, as the answer. Okay, we have that. So let's proceed now to the problem number 4. So the problem that we have for the number 4 is x squared plus 5x is greater than or equal to negative 4. So we have here now greater than or equal to negative 4. The negative is greater or equal to symbol. So then again, you have to follow this pattern that we have. And so the solution for this is we are going to extract the inequality that we have. It's the same as what we have done in our quadratic equation. It should be formed the quadratic equation. So here, since here is inequality, so we are going to form that one into standard form of the quadratic inequality, which is x squared plus 5x. Since negative 4 on the right side of the inequality, so as we transpose that one, so it became plus 4, which is greater than or equal to 0. So then again, we have now the numerical is 1, so to factor it out, then it should be the sum of 5. So we now have here 1, 4. If we're going to check then, so its sum now is 5. So So then now, as what we have from this given example, x squared plus 5x plus 4 is greater than or equal to 0, so the factor now is x plus 1, and the other one is x plus 4, which is greater than or equal to 0. Then again, every factor should be equated to 0, so x plus 1 now is equal to 0, so x is equal to negative 1. While the other one is x plus 4 is equal to 0, then x is equal to negative 4. So we could say further that we now have two roots that we have, the negative 4 and the negative 1 or negative 4, so, or just to say negative 4, since negative 4 is the lesser value than negative 1. So we could now say that x is greater than or equal to negative 4, or x is less than or equal to negative 1. And so, if we could have now the final answer for this, so therefore we could see further that the set of all x such that x is less than or equal to negative 4, or I stand corrected here, this should be greater than or equal to. Okay, we have now that there, so we have greater than or equal to negative 1, so greater than or equal to negative 1 as the answer. Okay, that is for number 4. So that is not the answer in problem number 4. So if we're going to go back to the given things that we have, so the answer now of this is okay, the answer now is this one. Okay, we have this for the given problem number 4. So we have that. As the answer goes. Okay. Now we should proceed to problem number 5. So it seems that the problem number 5 given is less than. So we could check now the given things that we're going to understand is less than. Just to say, we have this, and so the pattern now goes on this concept. So we have that. So here is we're looking for the given problem we're in using the diamond method. So this one is ax value, then this one is the product of a times c, and then here is the b. So the a here is 2, so we now have here 2x, then the other one is 2x. So the product of a and c is 22, then the c is 12, so 2 times 12 is 24, and then 11. So here we're looking for the factors of 24 wherein the sum is 11. So let's say 4, 6, its sum is 10, right? 2, 12, the sum is 14. Another one is 3, 8, the sum is 11. So in that case, we're now dealing with the given now that we have, which is 2x squared plus 11x plus 12 is less than 0. So we could now have over 3 here and over 8 here. Okay? So next thing that we should do for this is we're going to have to look for this 2 here, this one. So in that, since we have now the given factors that is 3 and 8, so all we have to do is to put it here, on this side here, and this one here, in both sides of the left side and the right side of our diamond method. And so Since the first row on the left side can be simplified anymore, so all we have to do is to write here 2x over 3 became 2x plus 3 is the first factor here. And then we now have, since we have the right side of the part of the diamond method, we have here 2x over 8. We are going to simplify that one first. And 2 and 8 is divisible by 2, so 2 divided by 2 is 1, 8 divided by 4, 2 is 4, so it became now x over 4 here. This one here, this one became x over 4. And so, as we write the second factor that we have is we have x plus 4 equals x plus 4. Now, as we do here, we are going to equate both factors to be 0. So the first one is 2x plus 3 equals 0. The other one is 2x plus 4 equals 0. And so to solve for x, the first factor we're going to transpose the plus 3 here. The other side became negative 3. And then we now have here 2x. Then divide both sides by 2. So we now have here cancel here. So what is now the remaining is x. Then negative 3 over 2 is negative 3 over 2. And we now have the value of x which is equal to negative 3 over 2. On the other side of the factors, we now have x plus 4 equals 0. So transpose the plus 4 on the other side, it became now x is equal to negative 4. So as we arrange this one, the lower value, the lesser value is negative 4, and the bigger value is negative 3. So since the given for number 5 is less than 0, so we now have here between s. So following this one here for number 1, and so the set of all x is that x in the set with the orientation x is greater than negative 4 but less than negative 3 over 2. So we now have that. And so this one is the answer. Okay. So here it goes. We have here given problem number 9. So we have 9x squared is less than or equal to 4. So to solve further for this is we're going to inequate the inequality. So this one becomes 9x squared minus 4 is less than or equal to 0. Since this is now a difference of two squares, so there is a pattern that goes for the difference of two squares. X minus x squared minus y squared is equal to x plus y and x minus y. So here we have, since this one is a perfect square, so the other one, now here 3x minus plus 2 and x 3x minus 2. So we now have here 3x plus 2 is equal to 0. Equate both factors to be 0. So 3x minus 2 is equal to 0. So we now have here 3x is equal to negative 2. Then divide both sides by 3. So x now is negative thirds. Then here we have 3x minus 2. So 3x is equal to 2 down. So divide both sides by 3. So x is equal to 2/3 now. So since it is now less than, so we have to select whether, so negative whether which of the two given groups is lesser than the other. So since negative 2/3 is lesser than 2/3, so we are going to arrange now here negative 2/3 then 2/3. So we can see now that the x is greater than or equal to negative 2/3 but less than or equal to 2/3. So the set of all x such that x is greater than or equal to negative 2/3 and the other one is greater than or equal to negative 2/3 but less than or equal to 2/3. That is now the answer in the given problem number 6. So looking back to the given that we have, if we're going to fill in the blank that we have, so we have here okay, so we now have that given now. So therefore, this is now the answer in the such thing that we have according to the given problem. So thank you so much for watching, and keep on watching as we go through with the future video lessons. But don't forget to subscribe and click the notification bell. So goodbye for now. See you then in next video lessons. Thank you.